Today we have to start the rational numbers. Objectives we have to look at V. Say at the end of this lessons you will be able to distinguish between natural numbers, whole numbers and integers, and define rational numbers, and learn their addition, subtraction, multiplication and division of rational numbers, and discuss the role of 0 and 1 for the rational numbers. Explain the additive inverse and multiplicative inverse rational numbers. Find rational numbers between any two given rational numbers. Number system. The whole number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to and so on. These are then whole numbers. 1 to up to and so on is these are natural numbers. Integers means included whole numbers and non-negative natural numbers. These are called integers. And 0, 1 by 2, minus 1 by 2, 1 by 2. 1 by 2, what about then 1 by 2? Here 1 by 2 in number is in the form of p by q, hence they call it as a rational number. A rational number is a number that can be written in the simple form, that is p by q, that is as an ratio. Okay, 1 by 3, 1 by 5, 1 by 7, 1 by 9 like that. P by q is a rational number. Q does not equals to 0. 5 and 3 by 1 by 3 and 1 by 4, 45, 6.4, 1.732. 5 is equals to 5 by 1, 45 is equals to 45 and 100. These are all any number we have to write in the form of 50. P by q form means that's a rational number. Simplifying the rational number. How we can simplify? 15 by 25 will be there. Okay, how we can simplify this? 5 3 is a 5 5 is a 25. Divide with the same number, okay, in the numerator and denominator. Numerator also the same number we have to divide, denominator also we have to same number we have to divide. Additions of rational number. How we can addition? Here both the numerator we have to denominator we have to see. This is a denominator. B and D are denominator. These are the and denominators. We have to multiply both the denominator in the numerator and the addition number. A into D plus B into C. A into D plus B into C. Additions of rational numbers or fractions. Additions of fractions. 5 by 4 plus 1 by 4. That will means 5 plus 1 is 6. 6 by 4. 6 by 4 is the answer. We had simplest form is 3 by 2. Subtraction of rational numbers, same as that as an addition of rational numbers. Same, we have multiplied with the cross one. We have to see for the first denominator. A into B, D minus B into C. We have to multiply with both A into D minus B into C upon B into D. For example, take it as an one example. 5 by 7 minus 1 by 7. 5 by 7 minus 1 by 7 is denominator will be in both, or 7 will be there. We have to write it as an 7 is an LCM. 5 minus of 1 is 4. 4 by 7. Multiplications of rational numbers. Multiplications of rational numbers is we have to multiply with the numerator to numerator, denominator to denominator. A into C is A into C, B into D is B into D. Hence we can write it as AC divided by BD. Okay, multiplications of rational numbers for some example here. We have taken 1 into 1 by 3 into T 3 by 5 is 1 into 3 is 3. 3 into 5. Okay, 1 into 3 is 3. 3 into 5 is 15. Simplest form is 3 ones are 3 5s. We have to divide additions of a rational numbers, and divide the rational numbers is A by B into D by C. Here A by D into D by C is A into D upon B into C. Keep observe it. In the divide there will be an changes. 6 by 1 multiply it becomes, okay, keep observe it. 1 by 4 into 6 by 1. 1 into 6 is 6. 4 into 1 is 1. 4 into 1 is 4. Okay, this is simplest form is 3 by 2. Role of 0. and 1. 1 divided by 7 plus 0. How we can add a rational number? 1 by 7 is an answer. 0 is an additive identity of rational number. We have to add with 0 of any number, then only we will get that number. What will be that number we only get. 1 by 7 into 1 is, this is also the answer is 1 by 7. Why then 1 by 7 it will become means here 1 is called the multiplicative identity of a rational numbers. Multiplicative of identity of a rational number. These 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, minus 1, minus 2, minus 3, minus 4. Okay, here plus 1, minus 1. Plus 1, minus 2. Plus 2, minus 2. Minus 1 is a negative or additive inverse of plus 1. Minus 1 is a negative or additive inverse of 1. 3 by 7 plus of minus 3 by 7 is additive inverse of 3 by 7. Minus 3 by 7 is additive inverse of 3 by 7. 7 by 19 into is equals to 1. What will be the value? 19 divided by 17. 7. Why? Because 19 that cancels, 7 that cancels. Why? Because 19 by 7 is the reciprocal or multiplicative inverse of 7 by 19. Here finding the rational number. Finding the rational numbers in between of rational number. In between. Okay. 1 by 4 and 1 by 2 will be there. 1 by 4 and 1 by 2. Here 1 by 4 and 1 by 2 and 3 by 8 lies between 1 by 4 and 1 by 2. How? Because how we will get here 1 by 4 plus 1 by 2 is equals to 3 by 4. 3 by 4 is divided by 2 is equals to this one. Summary. Let us summarize what we have learned. A rational number is a number that can be written in the form of p by q, where p and q are integers and q does not equals to 0. Rational numbers are commutative and associative under the addition and multiplication. 0 is an additive for the rational numbers. 1 is the multiplicative identity for rational number. The additive inverse of p by q is minus p by q of vice versa. Hi students, welcome back. Today we are going for rational numbers. I already given for some video and previous section rational numbers upon some animations of video. Now we will go for in your textbook what will be the given of rational numbers. Is the introduction is they given a sum of natural numbers, whole numbers and integers. They given some examples here. The rational numbers is in the form of p by q, where q is does not equals to 0. Here properties of rational numbers they given. I will explain.
Okay, now let's see under whole numbers. If we take addition, 2 plus 3 is equal to 5. 0 plus 4 is equal to 4. Anything 10 plus 20 is equal to 30. Any digits, any elements from the set of whole numbers, if taken and added, we get the element which is present in the whole number. So we can say the whole numbers are closed under addition. Now let's see subtraction. If we take 3 minus 2, we'll get 1 which is present in the set of whole number. Okay, now let's see a smaller element in the first place, that is, let's take 2, and minus 4. So we'll get it as minus 2. 2 minus 4 is minus 2, and minus 2 is not present in the set of whole number. Because of this, we can say whole numbers are not closed under subtraction, Now if we take multiplication, if we take any set of element, that is 3 into 2 will be 6, or 10 into 11 will be 110, or 5 into 4 will be 20. Every element is present in the set of whole numbers, so we can conclude that whole number is closed under multiplication. Now let's see for division. We can consider any element from the set of whole numbers for checking any of the properties. Okay, now if we consider 3, okay, let's take it as 6 divided by 3, we'll get it as 2. Then if we take 4 divided by 3, which is equal to 1.333 and so on. We represent this symbol for recurring digits, but this is not present in the set of whole numbers. This is actually a rational number. This became a rational number, so we can conclude that whole numbers are not closed under division. We can take anything, 5 by 2, which comes to 2.5, which is not present in the set of whole numbers. So we can conclude that whole numbers are not closed under division. Now let's see for integers. We know the set of integers is from minus infinity to minus 2, minus 1, 0, 1, 2, so on up to. So now if we take addition, we can consider any elements from the set. So I will take minus 3, and let me take plus, let me take 2, which will be equal to minus 1, and which is present in the set of integers. If we take 2 plus of minus 5, which will be equal to minus 3, which is present in the set of integer. So we can conclude that integers are closed under addition. Now if we take subtraction, we can take any element from the set. So let me consider minus 5 minus of 2, which will be equal to minus 7, and let me take 5 minus 4 which is equal to 1, anything, any elements can be subtracted and we get this elements which are present in the set of the integer. So we can also conclude that integers are closed under subtraction. Now let's see for multiplication. Okay, we can take an element minus 3 into minus 1 which will be equal to 3. You guys can see that minus of minus will get a positive number. If we take a negative number into a positive number, we'll get a negative number. Rule is plus into plus will give us plus, minus into minus will give us plus, minus into plus will give us minus, plus into minus will give us minus. You guys must need to remember this rule. This is the basics. You guys must need to remember this rule. Okay, yeah, as we saw, if we multiply any element present in the integer set, we'll get the element which is present in the integer set. So we can say that integer are closed under multiplication. Are closed under multiplication. Now if we take division, yeah, we can consider an element like if we take at starting minus 4 by 2, we'll get it as minus 2 which is present in the set of whole number. Okay, now let's take minus 3 by 2, we are gonna get minus 1.5. This is actually a rational number. This became a rational number. This is a integer. When we divide these two elements from the integer set, we get a rational number, and which the resultant is not present in the set of the integer. So we can conclude that integers are not closed under division. Now let's take the third one, rational numbers. Okay, we know that it must be of the form p by q and q must not be equal to 0. This is the condition. Okay, now let's take for addition. Okay, let's take 1 by 2 is a rational number and 3 by 2 is also a rational number, which will get 4 by 2 is a rational number. Okay, let's take minus 4 by 3 and 2 by 3 will get minus 2 by 3, which is a rational number. So we can conclude that rational numbers are closed under addition. Okay, Now let's take for subtraction. Okay, let's take 3 by 5 minus 1 by 5, which will get us 2 by 5, which is a rational number. We can take minus 3 by 5, maybe minus 3 by 6 and minus 5 by 6, which will be equal to minus 8 by 6, which is a rational number. So we can conclude that rational numbers are closed under subtraction. Now let's take for multiplication. Okay, we'll consider 3 by 5 into 4 by 6. We can further simplify, like 3 ones are 3 twos are, and 2 ones are 2 twos are, which can be finally written as 2 by 5, which is a rational number. Now we can take 4 by 7 into 2 by 3, which will be equal to 8 by 21, which is a rational number. We can take any number, minus 3 by 7 into 4 by 2, which will be equal to minus 12 by 14, which is a rational number. So we can conclude that rational numbers are closed under multiplication. Now if we take for division, we can take as I had mentioned earlier, 3 is a rational number which can be written as 3 by 1, and we can take 3 by 1 divided by 4 by 2. So we can write it as 3 by 1 divided by 4 by 2. We can see that this can be simplified. 2 ones are 2 twos are, and it can be written as 3 divided by 2, which is a rational number. But we know that this is the most important condition for a number to be a rational number. Okay, as I had mentioned earlier, we can write any integer or whole number or natural number in the form of rational number. For example, as I showed, 3 can be written as 3 by 1, 2 can be written as 2 by 1, minus 5 can be written as 5 by 1. Everything can be represented as in a form of a rational number. So if I'll take that 5 by 1 divided by 0 by 1, this is also a rational number, but the resultant 5 divided by 1 divided by 0 divided by 1 will be equal to 5 divided by 0, which is not a rational number, because q is equal to 0, so it is not a rational number. So we can say that rational numbers are not closed under division. You guys can think that why we didn't use this in multiplication. We can use, you can see 5 by 1 into 0 by 1, because this is a rational number, this is a rational number. We'll get it as 0 by 1, which is a rational number. So the rational number was closed. Rational number was closed for multiplication, but it is not closed